Hi, I'm Rich with Inside HPC. We're here at the GPU Technology Conference in San Jose, and I'm here with Dave Turek from IBM. How are you doing today, Dave?
I'm fine.
Great, great. Well, this week we saw the first instances of OpenPOWER hardware. What was your mission this week with that?
So the OpenPOWER hardware that was demonstrated this week is a physical manifestation that comes out of the work of the foundation over the last year and a half. It's meant to show that it's real, that people are doing real innovations, and there's a diversity of technology being deployed. You're seeing systems and cards being built for things that range from high-performance computing to cloud kinds of deployments. You even see people building things that are kind of ancillary innovations on top of powers that exist today. The FPGA cards, for example, where you're seeing customized function embedded in FPGAs, which in turn connect through innovations that we've made in interfaces to the power technology. So it's about diversity and breadth of uptake of the OpenPOWER technology.
Okay, and IBM showed a prototype in the swath of machines. It was based on OpenPOWER, and was NVLink in there, which is NVIDIA's interconnect technology?
Right, so the prototype shown on the floor, the so-called Firestone node, is a 2U, 2 GPU, 2 Power 8 system. It's a foundational technology for high-performance computing, but in this particular instance, the GPUs are still connected over PCIe. Within a year or so, we'll have those same GPUs implemented over NVLink. NVLink is a byproduct of a co-design collaboration effort between NVIDIA and IBM, and it's really meant to amplify the bandwidth between the CPU and the GPU. The issue is that the GPUs are getting progressively faster, and PCIe is becoming progressively more of a choke point. You're going to have fast GPUs that are just going to sit there waiting for data to be delivered. The innovation we've done in NVLink looks to ameliorate that situation.
And then you of course had the two big wins with the Coral systems that'll be based on Power 9, I think.
Yes.
Yeah, and with the GPU accelerators. Will the nodes for that, will they be these 2U type of systems like we saw yesterday?
Yes, it's quite probably still going to be a 2U form factor.
Yeah.
Those nodes will be foundational for the Coral systems, but they'll also be the same nodes we'll use in conventional HPC commercial applications.
Okay.
So we've set that up to create a cost point that makes it competitive for all ranges of the marketplace. It'll also have the second generation of NVLink, the improvement in bandwidth via PCIe connections. By that time will probably be 5x. You'll see cache coherence in play, and you'll see improved programmability at the same time.
Well, we've been talking about bandwidth and things and latency, but in HPC it's really application performance, and I saw your editorial piece today about a new white paper. Oh, what's that all about? It's saying LinPack just isn't enough anymore, is it?
No, LinPack actually hasn't been enough for quite some time, but I thought it was important for us to put some empirical information in the hands of customers and analysts alike to understand that this was a real serious issue that the marketplace has to deal with. Why do I portray it that way? LinPack as a metric is pretty narrow in terms of what it conveys about the architecture of a system. We've actually instrumented a large number of applications over a wide-ranging set of different HPC domains. And I think our general conclusion is that to get optimal performance, what you need is a system that really puts an emphasis on memory bandwidth, amount of raw memory, and integer performance. It doesn't mean floating point has gone away. It just means these other factors have to be understood to get a full appreciation for what the performance possibilities are. We took those ideas and embedded them in the Power 8 technology so that today you see tremendous performance improvements on Power 8, not because of floating point superiority, but because of these other architectural features that are in play.
Okay, well, it's going to be exciting to see this come to fruition, and I guess congratulations are in order for
Thank
the Coral wins.
A lot of people working on this, but the best thing about it is it's a community now.
Yeah.
We have more than 100 members of OpenPOWER. They're pushing in a lot of different directions at the same time, and you're going to see this expand quite dramatically.